All right, this is the third attempt at recording this video because I accidentally clicked forward in a slide and it won't let me click back when I'm doing the recording. So this video is to take you through activity 4.1.2, which introduces what cams are and gets you set to being able to design your own cam for your own automata. You can access the materials for this activity on the PLTW website, and you actually should make sure that you go in, because the very first thing that I'm going to ask you to do as part of this lesson is watch one of the videos that they have in their curriculum. I can remember I can only click one way in this PowerPoint. So first thing I would like you to do is watch the CAM mechanism video at the very beginning of activity 4.1.2 in the PLTW curriculum. It's about like 1 minute, 17 seconds or something like that. So go ahead, pause this video, click on over to that curriculum, watch that video, and then come back and we'll move on to the next thing. All right, so one of the things that he does is he goes over the CAM mechanism parts. And one of the things that I think made that first video that we watched so confusing is the woman in the video keeps tossing out this vocabulary when they haven't actually taught the vocabulary to you, which makes anything really hard to follow. So what I want you to do, and pause the video if you need to pause the video to do this, is to do a quick sketch of the CAM mechanism shown here in your notebook and then label the various parts. And the act of writing and labeling is going to help solidify that vocabulary in your head. So if I talk about the follower, you're actually going to picture the right thing in your head. You're not going to be picturing the wrong thing. So we do have several pieces of the CAM. This part right here is the actual CAM itself. And you'll notice the one in this picture is circular, but if you watch the video, which you were supposed to do, you'll know that not all CAMs are circular. The piece that goes through the hole in the CAM, that is the axle. And then this part here, we would typically refer to as the handle. This is the part that you would actually grab and turn with your hand. Then we have the follower. The follower is the part that goes up and down. So the follower rests on the CAM itself, and then as the CAM is rotating, the follower goes up and down with the profile of the CAM. And then in order to stop the follower from wobbling, there's often a guide on it. And all that is something that goes around the follower to just make sure that the follower keeps going up and down and it doesn't turn, because we know from real life and our study in engineering that things are imperfect, and even just a little bit of error with a measurement is going to cause something to wobble, and that could cause the device on top of the follower, which we usually call the topper, but we're not dealing with that in this lesson, to actually not move the way that you want it to move. So if you need to, pause the video and just sketch this down so that you have it in front of you. Okay, now this is an exercise that's actually in the curriculum itself, and I would like you to complete the exercise shown here by matching each CAM type with the number of the CAM that corresponds to it. Pause this video, or if we end up doing this in class and you're watching the video afterwards, we'll take time in class to do it, while you complete the exercise, and then resume play to check your answers. So you're gonna just put like a 1, 2, 3, 4, 5, or 6 into these blanks here. Okay, hopefully you paused the video to do that, because I did not wait long enough for you to do that. So here's what you should have answered. And this is a great question where you would maybe use process of elimination. So for example, CAM 4 is clearly a hexagon. So I would hope that if you got stuck on anything else, you would have gone over and put like CAM 4 as the hexagon. And we'll just go ahead and draw a line through that. What do we have? This here looks like a pear. It actually looks like a pear shape. When I did my PLTW training, I got really frustrated designing a pear cam because I was designing it in a way that looked okay, but it didn't cause Inventor to register the right points when the way that I was designing it. Anyway, in my frustration, I called it an avocado instead of a pear, but it is called a pear cam. And then my whole class called it an avocado cam. Looks a little bit like an avocado. All right. Circular. Now, circular you might want to hold off on because there are two cams there that are clearly circular. But we have heart, and when you look at the remaining pieces, there's one that does look a little bit like a heart. The indentation at the top is very, very subtle on the heart cam, but it is there. So heart is done, pear is done. That leaves us with snail, circular, and eccentric. Not eccentric, just it's eccentric. Cam, this one here that looks like the snail shell is 6. And then you're left between the remaining two. The circular one is the one with the hole in the center. So this would be 1. And then this one with the hole off center is 2. Okay, now what you should do right now is in your notebook, make any corrections. It's totally okay to get stuff wrong. I tell my algebra classes this all the time. Getting stuff wrong is part of how we learn. If you don't ever allow yourself to get stuff wrong, then you don't ever really learn. But if you did get any of them wrong, you don't want them to stay wrong. So take a moment and make any corrections that you need to make. Now, you might also want to notice, like, which of these do you think would be the easiest to design? Probably Cam 1 is the easiest to design. It's also really boring in terms of the motion it generates because the circle is in the center. And so whatever's resting on top of it is just going to stay the same distance away. The eccentric cam, that's actually really, really easy to design, and it does create some more interesting motion. The hexagonal cam, also pretty easy to design. The others take some creativity, and last year, though, I had several students that really took that on, and they wanted to try to design the different kinds of cams. All right. So what you are going to do is you are going to design the cam shown here in Fusion. And what I am going to do as soon as I'm done with this video is I'm going to go into Fusion and I'm going to record a video in Fusion demonstrating how you want to design this. Because if you remember what I said a few minutes ago, when I was doing this I had to design it as part of my summer prep before I went to the training. So I was trying to figure everything out on my own. The way I was designing it met all the specifications, but here's what I couldn't do. I couldn't get that hole in the correct spot. And it had to do with how I was designing the bottom part of it. Fusion, or in that case, Inventor, wasn't registering the bottom part. So what I'm going to do so that you don't get stuck in the same spot, because it's super, super frustrating to get stuck, is I will do a demo video in Fusion. So if you're not sure how to go about the design process, click on over to that video. And then what you will do is paste your final design into the class discussion channel in Teams, same way you've submitted your designs before. All right, now the rest of the activity, if you're following along with the activity in PLTW, the rest of the activity deals with something called parametric modeling. And there is a resource there that says the CAM dimension drawings, and it says CAM types with parametric dimensions. This is one of the PLTW resources you can click on. This is modeling where you set parameters instead of specific measurements. So you set the relationships that you want the measurements to have with each other, as opposed to just setting the dimensions themselves. So for example, you might define a measurement as being 1/4 of another measurement. So if you change one, the other will automatically change with it. So instead of saying, let's look at one of these cams here. So instead of saying, I want the diameter to be 12, and I want this distance from the center of the cam to the center of the hole to be 3, okay, which 3 would be 1/4 of 12. Instead, you would set the diameter to be a parameter called d, and then you would set that distance to be d divided by 4, or 1/4. That way, if you changed the diameter of the cam to, say, 20, this dimension here would automatically change with it to become a 5. And so it adds some flexibility to your design when you design parametrically. It can, if you know how certain things need to be related. So that's what parametric modeling is. Now, actually going into Fusion and setting up those parameters, that's what a big chunk of the rest of the lesson is. And in true PLTW fashion, they just like direct you to go look at the Fusion help or whatever. And yeah, so what I did was I went through some of that. So here is an example of one that I did with just a simple rectangle. I defined the width, and I'm sorry about that. When I say sorry about the typo, it's like I'm talking about right there where the H didn't type when I set that parameter. I defined the width as being half of the length. And so we've got this user parameter up here where it says the length is 20 millimeters, and then the width is, instead of the width being defined as its own measurement, the width is defined as half, or 0.5 times the length. And then over on the right hand side, you can see what those values are. Now, if I go in and I change the length, the width is automatically going to change with it. So here's your next task. You will create a similar sketch as follows. To go into Fusion, sketch a rectangle, and then finish that sketch. Then under the Modified panel, choose Change Parameters, and then you'll click to add a parameter. It'll look similar to what I have up on the screen there where it says User Parameters, and then see that little plus sign? You're going to click on that plus sign. Label this parameter the length, and then go ahead and set your length to a value of 50. Okay, just set it to 50. It doesn't matter for this purpose what unit you're in. So 50, if yours is in millimeters, great. If it's in inches, that's great too. Then click to add a new parameter. Label this the width. And then when you get to the part where it says value or expression, you're going to enter in 0.25 times length. And length should pop up as soon as you start typing it as a user-defined parameter. And then screenshot what you see and paste it in the discussion board as evidence that you completed this task. So it'll look something like what I have there, which just will demonstrate that you have gone into the option for defining the parameters and you've tinkered with that and you have some sort of sense of what the parameters are. And then we're going to stop the activity right there and move on to the next one. So I hope this video helps you make it through activity 4.1.2 in the event that I am not in class on the day when you started.